Alright, so I'm going to do the second half of section 2.1. So in the first half of section 2.1, the big thing that's going to definitely make it on the test is the kind of problems that I ended the section with that you might have just finished watching. But just in case it's been a little while, let me do a practice problem. This isn't from the handout. This is just a generic problem that I'm making up right now. So this is guaranteed to be on the test, and something that from this chapter carries through to other chapters. So it's a semi-big deal, I guess, to be good at this. And likely after today, I won't do a question like this again until the review for the test. So the kinds of problems that we saw in the first half of this video were something like this. I was given a fraction. I was asked to find the domain of it. Algebraically, this is going to be messy. But before I do the algebra, I know that my answer needs to look in words, something like this. The domain of x minus 3 over 6x squared plus 11x plus 5 is all real numbers except. And then the algebra I'm going to do up here is to get just the after the except part. And in terms of being lazy, if I would have said the domain is all real numbers except, and then did the algebra to find the numbers, that would be adequate. This part right here, the fraction of the problem, that's not such a big deal if you exclude that. So if in your answer you only wrote the domain is all real numbers except and didn't include the original problem in your answer, that's okay. That's getting ready to write the domain in words. When I get ready to write the answer in interval notation, it's going to contain the same numbers, but also some infinities and parentheses. And remember, when I go to write a domain in interval notation, I start off creating a number line that has negative infinity on the far left edge, positive infinity on the far right edge, and then any number I'm going to exclude from the domain I'm going to write in order between the infinities. So I'm almost have my answers done. I just need to find the numbers that are important or relevant, that come from this problem. So the algebra to get the domain, the first thing I do is I ignore the numerator. So I'm going to ignore that x minus 3. If I do anything with that x minus 3, I'll likely get a 3 in my answer, and putting a 3 down here in either of these pieces would tell me that if you plug 3 into the problem, you get undefined. And that's not the case. If you plug 3 in for x and simplify, you get 0, which isn't undefined. So 3 would be wrong to have in your answer completely. The second thing I need to do is I need to solve where the denominator, 6x squared plus 11x plus 5 equals 0. And the answer to this problem is going to give me the numbers to go after the except and the numbers that go on the number line. I purposely made this hard because we didn't do bottoms up factoring or factoring when there's a number in front of the x squared, and I know it's going to come up today. So if you're rusty on your factoring, then you might need to go back to my section think it's 1.3, where I explain how to factor this. So I'm going to do this factoring off to the side. So I'll call this side work. If you can factor 6x squared plus 11x plus 5, then you can get the numbers that need to be excluded from your domain easily. If you can't factor it, then I'll show you how I factor it, but seeing this once, if you've never seen it before, isn't going to be enough, and you're going to need to either come visit me or watch my videos from chapter 1. So my steps for factoring this kind of problem are going to be multiply first, factor, then divide, reduce, and bottoms up. So my goal is to break 6x squared plus 11x plus 5 into two parentheses that, if you FOILed them back out, would equal 6x squared plus 11x plus 5. And most of the high schools around campus use this method for factoring trinomials. So I'm going to multiply the 6 and the 5. That's the multiply part of my bottoms up. And I'm getting x squared plus 11x plus 30. So that's the first of my kind of 4 steps, but this last divide, reduce, bottoms up I do kind of in one big step. Next thing I'm going to do is I'm going to factor. This is easy factoring because there's no longer a number in front of the x squared. So I'm going to make a couple of x's for my firsts. There's no minus signs, so my signs can't have any minuses. They have to be a couple of pluses. My lasts have to multiply to 30 and add to 11. And 5 and 6, or 6 and 5 will do that. It doesn't matter if I do a 5 here and a 6 there, or a 6 here and a 5 there. I'll do a 6 and a 5. Now I'm done with the factoring portion of the bottoms up method. Now I'm going to divide. I started off multiplying the last number by 6. I'm going to end up dividing that last number by 6. That's the divide part of divide, reduce, and bottoms up. Now I'm going to reduce. The first fraction is reducible, so I'm going to reduce that 6 over 6 to 1. The second fraction, 5 over 6, is not reducible, so I'm done with the reducing part. Haven't done the bottoms up part. The bottoms up part has any fraction that doesn't reduce. You take that denominator and throw it in front of the x. That's how 6x squared plus 11x plus 5 is going to factor. So now, getting back to the problem, I'm going to replace the 6x squared plus 11x plus 5 with x plus 1 times 6x plus 5. So I have the equal to 0. And I'm ready to get the numbers that go in my answer. Now that I have the denominator factored and set equal to 0, I take the insides of the parentheses and set each equal to 0. So I take the x plus 1, set it equal to 0, the 6x plus 5, set it equal to 0. I subtract 1 from both sides for the x plus 1 and get x equal negative 1 as one of the numbers that I need to exclude. So in my answer for the domain written in words, one of the exclusions is negative 1, and somewhere on the number line I need to also put a negative 1 as I go to get my interval notation. There's going to be another number to exclude and another number for my number line. That's the number I get when I solve 6x plus 5 equal to 0. To do that, it takes 2 steps. I minus 5 from both sides and get 6x as minus 5. And then I divide both sides by 6. And I get x equals to negative 5, 6. When I'm doing the word domain, the order that I write the numbers in doesn't matter. I don't have to write the smallest one first and the biggest one second, or in any, there's no special order. So this would be writing the domain in words. I'm done with that. I'm not ready to write the interval notation until I get this negative 5, 6 on the number line. And negative 5, 6 actually on the number line goes to the right of negative 1. I don't write a 0 on the number line, even though you might be tempted to. You only write the infinities and the numbers that we're excluding from the domain. So I have my negative 1, negative 5, 6 and my infinities. I put some parentheses down and I create intervals. So the domain written in interval notation is going to have 3 intervals. The first interval is going to be from negative infinity to negative 1. The second interval is going to be from negative 1 to negative 5, 6. And the third interval is going to be from negative 5, 6 to positive infinity. Usually we put union symbols or use or the word or between the intervals. And in some sense, that's as good as you need to do. So both of these will be acceptable on the test when I ask you to find the domain. Even if the instructions say write your answer in words and interval notation, I'm not that concerned. If you did words only or interval notation only, I'm comfortable with taking one or the other. You don't have to give me both. And for most students, the interval notation is just a little bit tricky. It's just not that important. So don't worry so much about interval notation if it's kind of bogging you down. All right, so of the stuff from the first part of section 2.1, finding the domain of a fraction is the thing that is guaranteed to be on the test. The other things, plugging numbers in for x and reducing, as well as, well, that's all there was. Plugging numbers in for x and reducing, that won't be on the test. So 17 through 30 and the rest of the problems in section 2.1, the instructions somewheres in them have the word reduce to lowest terms. And there's easy problems and hard problems. The easy problems are the problems that don't have any adding or subtracting between the numbers and the letters. And in those problems, I can immediately go into the reduce mode. If there's addition or subtraction between the number and the letters, I will likely have to factor first. So I will attack this problem. This is the kind of problem you actually would have seen in beginning algebra if you took it on this campus. And in order to do this problem, I could use the rules of exponents, or I could dump off the exponents and just cancel in a easy to see way. So I'm going to solve this problem by writing it without the exponents. If you've already solved this problem and you get the same answer as me and you use a different method like subtracting exponents, that's probably better, and it's completely okay to use. So now that I have the problem written without the exponents, I'm going to reduce each kind of like term. So I'm going to reduce the 25 over 15 as a fraction. 25 over 15 reduces by 5, and I'm going to reduce the 25 by 5 and the 15 by 5. If you want to be lazy, this calculator will reduce fractions for you. If you just enter the fraction 25 over 15 and hit enter, it tells me that the fraction reduces to 5/3. So if you're slow at reducing fractions, if you just enter the fraction on this calculator, it will reduce it for you. It knows how to reduce. So 25 divided by 5 is 5. 15 divided by 5 is 3. That's the number part. Now I'm going to start canceling out x's. Any time there's a pair of x's, one in the numerator, one in the denominator, I can cancel them. So there were 3 x's that I could cancel, which left me with no x's in the denominator, but in the numerator that I was still left with an x. And I'm going to leave that x there. So this is what I would say the answer is. And I'm done. It's optional and kind of hard to check. And it's kind of awkward to check. I don't think I could spell awkward this morning, so I won't. So optional, and the way that we check the problems between 17 and 30 isn't a slam dunk, meaning that if your check works, it's not guaranteed that your algebra is right, but it's likely right. So to check for these problems, you pick any number in the domain of the problem for x. And I wouldn't pick 0 or 1. So I'm going to pick any number, replace x in the original problem, and replace x in my answer with that number and reduce. For my answer to be correct, I have to have the same simplification. So the original problem is this. My answer is this. So for whatever reason, I don't want to pick 0 and 1 because they're almost too simple of a number to use. So I'm going to let x equal to 2, which is a number that's somehow interesting. And I'm going to put it in the original problem for the x's. And I'm going to put it in my answer for the x's. When I do this computation and this computation, if I get the same number, then I think my answer is correct. So I'm going to do this both on my calculators. This first computation, I changed the x to 4 because of the exponent in the multiplication. I put a parentheses where the x was. So for this side, I'm going to go 25 parentheses 2 parentheses, hit the x with the exponent key, the x with the squared key right next to the x squared key, type of 4, and then do down and do 15 parentheses 2 x with the square 3. So that looks exactly like this, and this reduces to 10/3. For my answer to be correct, it also, when I plug 2 in, has to reduce to 10/3. I can do that without my calculator, but I'll use my calculator and do this computation. Go 5 parentheses 2 over 3. And because when I took the number 2, plugged it into the original problem, plugged it into my answer, because I got the same number both times, then I think my answer is correct. So I'm done, but a common wrong answer for this, every now and then a student will put the x in the wrong place. And I can show you how I could have found out this was a wrong answer. So if you worked ahead of me and you got this for an answer, and you put the x in the denominator and did this strategy of checking, if I put 2 in for x, did 5 over 3 times 2, that would come out to 5/6, which is not the 10/3. And so I could tell that this 5 over 3x is not a correct answer, because when I plug 2 into it, I get a different number than plugging 2 into the original problem. And so anytime I come up with an answer for any problem between 17 and 30, I can take the number 2, as long as it doesn't give me undefined, plug it into the original problem and in my answer. If I get the same number doing each of the substitutions, I'll think my answer is right. 20 has 2 letters, so if I wanted to check with 20, I'd have to pick a number for x and a number for t. Let me reduce 20 just like I reduced the last problem, meaning I'm going to write 20 without the exponents. So in the numerator, I wrote 3 x's and 2 t's. In the denominator, I wrote 1 x and 6 t's. I left the 14 over 21. Now I'm going to reduce the fraction 14 over 21. That's not hard for me to reduce, but if I'm not good at reducing it, I could just enter the fraction 14 over 21, and this calculator will tell me that it reduces to 2/3. Basically, I'm just dividing 14 by 7 and 21 by 7 to get the 2/3. So in my answer, I'm going to have a 2 in the numerator, a 3 in the denominator. Now I'm going to work on canceling the x's. I have an x in a numerator and an x in the denominator that I'm allowed to cancel. 2 x's left in the numerator that have nothing to cancel with. I'm going to leave those 2 x's in the numerator and write them with an exponent. So after I'm done with the x canceling, I'm left with 2 x's in the numerator, so I have an x squared left in the numerator. Now I'm going to go to the t canceling, cancel 2 t's from the numerator with 2 t's from the denominator. I'm left with 4 t's in the denominator, and instead of writing 4 t's, I'm going to write something equivalent to 4 t's, which is t to the 4th power. So again, if I want to, it's optional. These problems are simple enough. And I'm going to pick different numbers for x and t. I'm going to go to the original problem and go 14 times x cubed, which is 2 cubed, times t squared, which is 3 squared, over 21 times x, which is 2, times t to the 6th, which is 3 to the 6th. I'm going to do that computation on my calculator, and I'll do the same thing to my answer. I'm going to go, in my answer, I'm going to go 2 times 2 squared, plugging a 2 in for the x in my answer, and in the denominator 3 over times 3 to the 4th. So I'm going to do each one of these computations. First computation, 14 parentheses, 2 cubed, parentheses, 3 parentheses. I could just hit the squared key. When I entered the 2 cubed, I hit my right arrow to get out of the exponent. I'm going to go to the denominator, 21 parentheses 2 parentheses 3 parentheses exponent 6. So that's this fraction. It reduces to 6 over 243. That's plugging the numbers 2 for x and 3 for t in the original problem. I'm going to do the same thing to my answer. Plug in 2 for x, 2 parentheses, 2 parentheses. I could hit the x squared key to get the 2. And then go down, 3 parentheses, 3 parentheses, the x with the square key, and 4. Looks just like the problem. I hit enter. Gives me 8 of, whoops, I might have written down wrong the last one. I'm concerned here. I don't know how to go backwards on this calculator, but I get 8 over 243. It might have said 8 over 243, and maybe my eyes are just old and I might have messed up here. Let me redo this one. Sorry. So 14 parentheses 2 cubed, right arrow, parentheses 3 squared, down, 21 parentheses 2 parentheses 3 squared to the 6th, enter. It is 8 over 243. Oh. So that was just my eyes failing me, because that's what happens when you get old. So because when I plug the numbers 2 and 3 in for x and t into both the original problem and my answer, because I'm getting this got the same answer, I assume my answer is correct. I'm not going to check 22 because it'll take forever and you'll go crazy anyways. So on 22, the negative 18 is not a negative exponent, it's just a simple negative number. And when I reduce a negative divided by a positive, I'm going to get a negative. So I'm writing the problem without the exponents. And the first thing I'm going to do is reduce the fraction negative 18 over 24. If I did it on this calculator, I type the fraction button. To get a negative 18, I type the negative that's in the parentheses. The negative in the parentheses below the fraction key gives me negative numbers. So I do negative 18 over 24. When I hit enter, it tells me it reduces to negative 3/4. The negative sign, it writes to the left of the fraction. It would be okay to attach the negative sign to the 3 in the numerator, or it'd be okay to attach it to the 4 in the denominator. Because the negative's already in the numerator, I can leave it there. So in my answer, it will be equivalently correct if I had a negative 3/4 like this, or if I left the negative out front and just wrote 3/4 for the number part. It's not done because I haven't dealt with the letters, but when you have negatives, a negative number in the numerator of a fraction, you can take that negative and just move it out front. Now I'm going to reduce the x's. I'm left with 1x in the denominator. Reduce the y's. I have no y's left for my answer because they both canceled. And reduce the z's. I have 2 z's left for my answer, and they have to be in the numerator. Those 2 z's I'm going to write as z squared. So both of these would be correct answers. I generally would leave the negative in the numerator rather than write it out in front of the fraction, because sometimes I miss that negative if it's not written in the numerator. So I'm done. I could check that, but I'm not going to check that. 24 is the first problem where I see a term with a plus or a minus. Terms with pluses and minuses cancel if they're identical. 24, there's no exponents for me to expand, so I'm just going to reduce. First, the fraction 12 over 36. Yeah, I'll be lazy again. Fraction 12 over 36. That reduces to 1/3. And so in my answer, I know I'm going to have the number 1/3. It turns out that's all I'm going to have in my answer, because a y minus 7, because it's identical to the y minus 7 between the numerator and the denominator, they cancel and they turn into 1s. So I claim that this is my answer. And if I want to check, I need to pick a number for y. Let me say if I let y equal to 2. In the original problem, I'd go 12 times 2 minus 7 over 36 times 2 minus 7. So that's checking in the original problem. In my answer, there's no place to plug the 2, so it better happen that this reduces to 1/3, because in my answer, there's no y's. So that tells me no matter what number I plug in for y, this should reduce to 1/3 unless I pick something outside the domain of the original problem. So fraction 12 parentheses 2 minus 7. I used this minus because it's a subtraction as opposed to a negative number, divided by 36 parentheses 2 minus 7, enter, and it reduces just exactly what I needed to. It reduces to 1/3, which is the same as the answer, so I know my answer is correct. So checking is optional, but if you have the time, it can't hurt. '26 is where the students that don't do their homework and just think they know it by watching the videos. This is the kind of problem that will come on the test and kind of bite you, because the rules of canceling are different when there's pluses or minuses between the terms than if there's not. So first of all, hopefully it's obvious that you can cancel the p minus 3's. So let me say that this might be an answer. This is my first attempt at an answer. I'm real comfortable with canceling the p minus 3's and leaving a p plus 4 in the numerator and a p minus 6 in the denominator. If I wanted to check this, I'd have to pick a number for p. Let me do 2. Plug it into the original problem and go 2 minus 3 times 2 plus 4 over 2 minus 6 times 2 minus 3. So if I put 2 into the original problem, did parentheses 2 minus 3 parentheses 2 plus 4 over parentheses 2 minus 6 parentheses 2 minus 3. When I do that reduction, my calculator tells me this is negative 3/2. I'll do the same thing to the thing I'm calling my first attempt for an answer. I'm going to go 2 plus 4 over 2 minus 6. And when I do that, fraction 2 plus 4 over 2 minus 6, when I hit enter, I get negative 3/2. I know that this is a correct answer. The question is, can I go further? The answer is going to be no. So this can't be reduced. And so some common mistakes. So this is the first attempt of the answer. It's actually the right answer. Some common mistakes would be to reduce this 4 and the 6, reduce the 4 by 2 and the 6 by 2 to make this p plus 2 over p minus 3. Let me do the same thing with this. If you thought this was an answer and you plugged 2 in for p, you'd go 2 plus 2 over 2 minus 3. And fraction on my calculator, 2 plus 2 over 2 minus 3. When I hit enter, my calculator tells me this comes out to negative 4, which is not negative 3/2. So I know that that answer isn't correct because when I plug the number that I plugged into the original problem into my first attempt at an answer, I don't get the same number. If you went further and said, well, maybe I can reduce these to ones, and you said this should be 1 plus, really, this is not good, and that actually equals to what my check is. And so let me show you. So this is 1 plus 2 over 1 minus 3. This comes out to be, badly, and this is a flaw of this checking method, is you can think your check works and it could deceive you. So if I did that canceling, it looks like it works. Well, just because it works for p equal to 2 doesn't mean it's going to work for every p. Let me show you that this answer isn't generally correct, because if I would have picked another number and put it in the original problem, like p equal to, I don't know, how about 5? If in the original problem I did 5 minus 3 over 5 plus 4 divided by 5 minus 6 over 5 minus 3, for this answer to be correct, being able to cancel the 4 and the 6 and the p, this would have to reduce to negative 3/2, because in this version of an answer, there's no p's, which would tell me every time I reduce, I get negative 3/2. And if I do this, parentheses 5 minus 3, parentheses 5 plus 4, over parentheses 5 minus 6, parentheses 5 minus 3. When I do that, I get negative 9, which is not negative 3/2. So this style for checking, picking a number and seeing if plugging the number into the original problem and plugging the number into your answer give the same number, it's a flawed strategy, in that just because it works for one number doesn't mean it works for every number, but it's the best we can do. So the big thing that this problem is supposed to highlight is the difference between reducing when you have pluses and minuses between terms and not. So I'm going to leave the text for a little bit, and just to emphasize this, these are extra. Not in the handout. If I gave you something like this, and if I said reduce x plus 5 over x plus 10, you're supposed to say this can't be reduced. And if you thought you could reduce it, then I can check to see if we're right or wrong. So a common error would be to reduce the 5 and the 10. If you reduce the 5 and the 10, you'd get x plus 5, x plus 1 over x plus 2. So if you reduce this, now to check to see if that's right, I should be able to take any number for x. I like doing 2 generally, so let me do 2, plug it into the original problem, and do 2 plus 5 over 2 plus 10, do it into my wrong answer, 2 plus 1 over 2 plus 2, do these both on my calculator. First fraction, 2 plus 5 over 2 plus 10, reduces to 7/12. For this answer, x plus 1 over x plus 2 to be correct, this would also have to be 7/12. And if I do this, 2 plus 1 over 2 plus 2, comes out to be 3/4. So the fraction x plus 5 over x plus 10 doesn't reduce to x plus 1 over x plus 2, because when I plug in 2 for x in the original problem, I don't get the same thing as plugging in 2 in my answer. If you thought you could reduce more and reduce these x's too and made this 1 plus 1 over 1 plus 2 and said the answer is 2/3 and it doesn't have any x's in it, that would imply that for any number I'd plug into the original problem, I would get 2/3. So this doesn't reduce into x plus 1 over x plus 2, because when I plug 2 into the original problem, into this, I don't get the same number. I can't do both the 5 and the 10 and both the x's, because that would make this reduce to 2/3, which would say anytime I plug a number in for x, it reduces to 2/3. So when we have terms that have pluses or minuses between them, they don't reduce unless this was an exact x plus 5 over x plus 5 over or an x plus 10 over an x plus 10. That's different than this problem, which to a lot of students seems the same. But if I asked you to reduce 5x over 10x, which, I mean, it doesn't look that different. I mean, they both have x's and 5's in the numerator and the denominator. The difference being this one is straight multiplication. This one, there's pluses between the terms. When there isn't any adding or subtracting, reducing is, you can almost not go wrong. You can reduce any like terms between the numerator and the denominator. So for this one, this is actually reducible. I can reduce this 5 with this 10. 5 divided by, well, let me do my calculator again so I can be lazy. 5 over 10 reduces to 1/2. And I cancel the x's. And I'm left with just 1/2. So I think that this original problem, 5x over 10x, reduces to 1/2. If I wanted to check, there's no number to plug in for x into my answer, but in my original problem, if I did like let x equal to 2 and did 5 times 2 over 10 times 2, for my answer to be correct, this better reduce to 1/2. So let me just do that. Fraction 5 times 2 over 10 times 2. And when I do that, I get 1/2. So when I plug 2 into the original problem, I get something that's equal to my answer. That tells me that my answer is most likely right. So the big thing that's going to carry through the rest of the chapter is knowing when you can and you can't reduce. So I'm, again, leaving the text a little bit more and let you try a couple of these. So if I asked you to reduce these 4 separate problems, so this is kind of 1, 2, 3, 4. If I asked you to reduce each of these 4 you should be able to know what you can and can't do. This one, it can't be reduced. And if you try to reduce it, you can pick a number for x, plug it into your answer, and plug it into the original problem. Likely the numbers won't match. Similarly, this can't be reduced. So these 2 problems, the x plus 3 over x minus 6, y plus 2, and over y minus 8, what they have in common is there's a plus or a minus between the letter and the number. And in order to reduce, you have to have exact copies. If I made another problem like x plus 5 over x plus 5, that can reduce, and it reduces to 1, because both of these completely cancel, and when they cancel, they turn into 1s. So I cancel the x plus 5 with the x plus 5, I'm left with 1 over 1, which is 1. The only time if you have a plus or a minus between a number and a letter that you can cancel is exactly this, when you have identical terms or identical factors between the numerator and the denominator. These bottom 2 you can reduce. Here I can reduce the 3 and the 6. 3 divided by, well, again, I'll do this on my calculator just to be lazy. 3 over 6 is 1/2. So the number 3 over 6 reduces to 1/2, and the x's cancel. So this 3x over 6x reduces to 1/2. This 2y over 8y, again, because there's not a plus or minus between the terms, I can reduce the fraction 2/8 to 1/4. So fraction 2 over 8 turns into 1/4, and I can cancel the y's. So this reduces to 1/4. So that's hugely important in terms of the next section and the rest of this section. Knowing when you can and can't reduce when you have fractions. When there isn't any adding or subtracting, I can cancel any number with any number, any letter with its like letter. But when you have adding or subtracting, you can only cancel if you have an exact copy. Alright, so now I'm going to get back into the handout and do problem 28. And in problem 28, I see pluses and minuses, so I know I could only cancel exact copies. An x minus 1 in a denominator has an exact copy of an x minus 1 in the numerator, so that can cancel. There's an exact copy of an x plus 3 in both the numerator and the denominator. Those can cancel. A single number without a letter added to it or subtracted from it will never cancel with a number added or subtracted to a letter. So I claim that my answer, the most I can reduce this, is the 15 over x plus 2. And if I really wanted to, it's a nuisance, but I can check. I can pick any number for x. Again, picking 0 and 1 will cause me more trouble than that, in that I could get my answer, when I plug the number into the original problem in my answer, that conflict of getting the same number even though your answer is wrong can come up a lot. So I'm picking 2. I'm going to plug it into the original problem and go 15 times 2 minus 1 over 2 plus 3 divided by 2 minus 1 times 2 plus 2 times 2 plus 3. So in my original problem, if I plug 2 in for x and go 15 parentheses 2 minus 1 parentheses 2 plus 3 over parentheses 2 minus 1, 2 plus 2, and 2 plus 3, doing in my original problem, plugging in x equal to 2, I get 15 over 4. And in my answer, if I plug x equal to 2, I get 15 over 2 plus 2. I don't even need my calculator for that, but I'll use it. I'll go 15 over 2 plus 2, and I get 15 over 4 again. And that's a good thing. So I feel good that this answer is correct, because when I plugged the number 2 into the original problem, and my answer, I got the same number. And that's what you need for a correct answer. But it's not enough for it to just work for x equal to 2. It needs to work for every x. But I'm only going to check one number. At some point, I just get fatigued and I just don't want to check anymore. Ooh, 30. I can't cancel a letter with a plus sign with a single number. Single numbers can only be canceled with single numbers. They can't cancel. It'd be illegal. So if you did this would be a common mistake. If you canceled the 12 with the 24, so if I do, in fact, if you cancel the 12 with the 6, because the 12 doesn't have a number, the letter, the 6 doesn't. If you cancel the 12 with the 6, so 12 over 6, and you'd get 2. If you made this a 2 and left the 24 be, and you changed the 6, so if you just canceled these, because those are both numbers without letters, you'd get 2 over 25 for an answer. And that would mean if I took any number and plugged it in for b, I'd get 2 over 25. If I wanted to check that, so if I let b equal to 2, I'd get 12 over 24 times 2 plus 6. Fraction 12 over 24 times 2 plus 6 gives me 2/9. So I can't cancel the 12 and the 6, because if I cancel the 12 and the 6, the 12 becomes a 2, the 6 becomes a 1. This whole fraction reduces to 2 over 25, which would tell me that if I took the number 2 and plugged it in for b, it should also equal 2 over 25, but it doesn't. I can't cancel single numbers with single numbers that have a plus sign lagging. So in order to get 30 solved correctly, I need to factor the denominator and produce a single number that's kind of free of the plus sign. And in the denominator, both 24 and 6 are divisible by 6. I'm going to factor out a common factor of a 6. So I'm going to rewrite the denominator. It's the first denominator that we've had so far that could be factored. And I'm going to put a 6 to the left of a parentheses because 6 is a common factor of 24b plus 6. Now I'm going to divide 24 by 4 and get a 4, leave the b, leave the plus sign, divide 6 divided by 6 and get 1. What I've done now is produce a single number in the denominator that's free of the plus sign. And single numbers free of plus signs cancel with single numbers. I'm going to cancel this 6 and this 12. 12 divided by 6 is 2. 12 divided by 6 is 2. 6 divided by 6 is 1. I claim that this is going to be a correct reduction. And my correct reduction is going to have that 2 in the numerator, just like in my wrong answer. But in the denominator, I'm just going to have the 4b plus 1. I've canceled the 6, it turns into a 1. Means I don't need to write the 1 and I don't need the parentheses anymore. Well, let me put 2 into this answer. When I plugged 2 into the original problem, I got 2 over 9. It better be the case when I plug 2 into my answer that I get 2 over 9. So when I go 2 over 4 times 2 plus 1. For this answer to be correct, I need to get 2/9. And let me try that again. I can do these in my head, but sometimes it's more convincing on my calculator. And that's perfect. Because when I plug 2 into the original problem and when I plug 2 into my answer, because they both reduce to the same number, I believe that my answer is correct. So the important thing about this problem is that some problems can't be reduced how they're written, but you can factor and make them reducible. In most of the rest of what we're going to do, that's going to be the case. For the rest of the problems, 31 through 38, and the last group of problems, every one of these problems, the way they're written, they can't be reduced. So in problem 32, I can't cancel this x with this x squared, nor can I cancel this 15 with this 9, because a 5x plus 15, because of the plus sign between the 5 and the 15, it can only cancel with another 5x plus 15. The rest of the problems in section 2.1, I'm going to have to factor first and cancel. And most of the factoring here is pretty easy. So for this problem and the rest of the problems between 31 and 38, I'm going to factor. And then after I factor, I'm going to cancel. And then if I'm not feeling super lazy, I'm going to check. So 2 factorings. The numerator doesn't have a square, so I can't get 2 parentheses. The best I can do in the numerator is have a 1 parentheses common factor factoring, and both 5 and 15 are divisible by 5, so there's a common factor of a 5. I'm going to divide the 5 and the 15 by 5 and leave the plus sign, and have an x plus 3 left over. This is section 1.1 factoring if you are rusty on your factoring. The denominator is a difference of squares. You get 2 identical parentheses, one with a plus sign, one with a minus sign, and you take the square root of the number. So x squared minus 9, that's in section 1.4 if you forgot how to factor that. Factors into x plus 3 times x minus 3. So I've done my factoring. In these problems between 31 and 38, if you factor properly, something will cancel. If you factor wrong, nothing will cancel. So I think this is my answer. I'm going to check. I'm going to plug 2 in for x into this problem, in the original problem, 5 times 2 plus 15 over 2 squared minus 9. And I'm going to plug 2 in for this into my answer. If they both reduce to the same number, I believe I have the right answer. If they don't reduce to the same number, I know I'm messed up. So first, easy checking. So 5 parentheses 2 plus 15 over 2 squared minus 9. So when I plug into the original problem 2 for x, my calculator tells me this reduces to negative 5. Do the same for my answer. Go fraction 5 over 2 minus 3. And when I do to my answer, I also get negative 5. Because when I plugged in 2 into the original problem and into my answer that I got the same number, I think my answer is correct. So the answer for 32 is going to be 5 over x minus 3. It would be nice if you could do 34 independent of me, but if you can't, it's okay. You can just watch me do it. So step 1, you can't cancel because when terms have pluses or minuses between them, you can only cancel when they're exactly the same. The numerator doesn't have a square, so it's not going to be 2 parentheses, it's going to be a 1 parentheses common factor factoring. And in the numerator there's a common factor of a 5. When I factor out that 5, I take and divide each of the 5s by 5 and get an x minus 1. The denominator, I know my first have to be a couple of x's. I used a template to know that my signs are minus and minus. My lasts are both going to be minus. And they have to multiply to 6. Technically, they have to add to negative 7. So my choices for my lasts would be minus 1 and minus 6, or minus 2 and minus 3. And if I look at minus 2 and minus 3, when I add those, I get minus 5, which isn't minus 7. Those can't be right. Minus 1 and minus 6, they multiply to 6. And minus 1 and minus 6 add to negative 7. So those are the correct lasts. Not doing anything with domain, so I'm not taking x minus 1 and x minus 6 and setting it equal to 0, because I only do that step when the instructions say find the domain. The instructions here just said to reduce, and reducing a fraction has nothing to do with setting the denominators equal to 0. So I'm ready to do the canceling. Cancel the x minus 1s. I claim that this is my answer. So I think the answer for this is 5 over x minus 6. Step 3 is optional, but it's not a bad idea to do my checking. I'm going to put 2 in for x's. So in the original problem, I'd go 5 times 2 minus 5 over 2 squared minus 7 times 2 plus 6. And in my answer, I'm going to go 5 over 2 minus 6. See what happens when I do that. In the original problem, if I do 5 times 2 minus 6 over 2 squared minus 7 times 2 plus 6. When I plug in 2 for x in the original problem, I get negative 1. When I plug in 2 for x in my answer, I get 5 over 2 minus 6. Oh, I get negative 5/4. This is not comforting, but I may have made a mistake somewhere. Maybe I entered this wrong. I think maybe I made a mistake. But is the mistake in my algebra or is the mistake in my calculator? Let me redo this checking here because I don't think I have a mistake up here. Let me redo this. Fraction 5 parentheses 2 minus 5. That's doing 2 and then x for the numerator. And then over 2 squared minus 7 times 2 plus 6, plugging 2 into the denominator. So I just did something wrong on my calculator. I was pretty sure this was the right answer. So when I get a mistake down here in my checking, I have two choices. Either I screwed up here with my checking, or I screwed up with my factoring, and I knew that my factoring was right, so I double checked my calculator work. I don't know what I entered wrong, but something, when you watch the video, you saw me mess up. So the answer is 5 over x minus 6. The step 3 is completely optional, but you can do it. 36, both the numerator and the denominator have squares, so they're both 2 parentheses factorings. And you can't cancel until you factor. So I'm going to rewrite this problem. Step 1 is going to be factoring. The numerator, I know I have to have a couple of b's up front. My last have to technically multiply to negative 6, and I'd say subtract to be the number in front of the b, which is a 1. In my videos in section 2.1, I tell you that the signs have to be plus and minus. So the numbers for my lasts could be a plus 1 and a minus 6, a plus 6 and a minus 1, a plus 3 and a minus 2, or a plus 2 and a minus 3. So when I'm going to factor the numerator, I know that my signs are plus and minus, and I need to pick the pair to give me the plus 1b, and 1 and minus 6 give me a minus 5. Those won't be the good pair. 6 and minus 1 give me a positive 5. That's not the good pair. This is the good pair, a positive 3 and a minus 2. Positive 3 and minus 2 combine to give me a positive 1, which is the number in front of the b. When I go to factor the denominator, I know my first have to be a couple of b's. One of the numbers has to have a plus, one of the numbers has to have a minus. I have to multiply to be 8. So I could get positive 1 and minus 8, positive 8 and minus 1, positive 4 and minus 2, positive 2 and minus 4. All those numbers have a plus and a minus, and they multiply to be 8. I need to get the positive 2 out of these. There I see a minus 7. There I see a positive 7. Positive 4 and minus 2 are going to give me a positive 2, because 4 minus 2 is 2. So I'm going to put a positive 4 and a minus 2 in. And now I'm going to cancel. B minus 2's cancel with B minus 2's. And I claim my answer is B plus 3 over B plus 4. I'm going to check. I can't put b equal to 2 in. If I plug b equal to 2 into the original problem, I'm going to get undefined. And the original problem and my answer, they're equal for every number but numbers that aren't in the domain of the original problem. So let me pick 3, because 3, I'm not going to get a 0 in the denominator. If you try to check with 2, you're going to see that you're going to get a domain error, or whatever your calculator this calculator does to show errors. So I'm going to plug in 3 to the original problem for B, and 3 in my answer for B, and make sure they both come out to the same number. So plugging 3 into this original problem, fraction 3 squared plus 3 squared plus 3 minus 6 over 3 squared plus 2 times 3 minus 8. When I plug 3 into the original problem, assuming I haven't messed up, I get 6/7. When I plug 3 into my answer, 3 plus 3 over 3 plus 4, I also get 6/7. So because my check worked, this answer is likely correct. 38, bottoms up factoring in both the numerator and the denominator. So let me deal with both factorings off to the side. So this is, I call this side work because it's long. Bottoms up factoring. And bottoms up factoring has me multiply, factor, divide, reduce, and bottoms up. So I'm going to do each factoring separately. So the first hard factoring is 6x squared minus, I'm going to emphasize 1x minus 1. I'm going to start off the multiplying part of bottoms up factoring and multiply this 6 and that minus 1 and get a minus 6. The 6 is going to leave the x squared and become part of the last. So that gives me x squared plus minus 1x minus 6. Now I'm going to factor that, and it's not terribly hard to factor. It factors into x plus 2 and x minus 3 because 2 minus 3 is negative 1 and 2 times minus 3 is minus 6. So I've multiplied, factored, now I'm going to divide. I started off multiplying by 6. I'm going to end up dividing by 6. Reduce. The first fraction, 2 over 6, reduces to 1/3. The second fraction, 3 over 6, reduces to 1/2. And both have a bottom to bring up. The 3 is going to go in front of the x for the first parentheses, and the 2 is going to go in front of the x in the second parentheses. So the numerator properly factors into 3x plus 1 times 2x minus 1. Done with first bottoms up factoring, I'm going to do my second bottoms up factoring and do 2x squared plus 9x minus 5. First step in bottoms up factoring, multiply. So I multiply the 2 and the minus 5 and get x squared plus 9x minus 10. Factor. First are a couple of x's, signs are plus and minus. Last have to multiply to 10, subtract a positive 9, that's going to be a positive 10 and a minus 1, because 10 times negative 1 is negative 10, 10 minus 1 is 9. Started off multiplying by 2, I'm going to end up dividing by 2. First fraction reduces perfectly to x plus 5. Second fraction is already reduced, so I'll do the bottoms up part for it and get a 2x minus 1. So the denominator, when I factor it, it factors into x plus 5 times 2x minus 1. Now I'm ready to cancel. The 2x minus 1s are going to cancel, and I'm going to get something that I think is the correct answer. It's going to be 3x plus 1 over x plus 5. Again, it's just not that hard to check. And I'm going to just plug in 2 for x, and it's going to get messy here. So for my checking, I'm going to go 6 times 2 squared minus 2 minus 1, and then 2 times 2 squared plus 9 times 2 minus 5. Let me do that real quickly. So I'm checking by plugging in 2 for x. So 6 parentheses 2 squared minus 2 minus 1 over 2 parentheses 2 squared plus 9 times 2 minus 5. Double check that to make sure I'm not messing up. That looks like I get 1 when I plug in 2 for x. Let me do to my answer. If I do 3 times 2 plus 1 over 2 plus 5, I better get 1, otherwise my answer is not correct. So fraction 3 parentheses 2 plus 1 over 2 plus 5. So plugging in 2 to my answer, I also get 1. So I believe my answer is correct. So that's the end of that style of problem. The rest of the problems are likely not on the test. I probably wouldn't go crazy when I'm studying for the test focusing on these problems, but I'd probably still watch the video, even knowing the problems are likely not to be on the test. So in each of these problems, the letters are either not lined up under each other, or the problems are going to need to be factored, or both. In problem 40, to figure out how to reduce it, I'm going to rewrite the problem to line up the letters. And very specifically, that 3 minus y, it looks odd to have the y written second and the 3 first. So I'm going to write the y first. And when I write the y first in the denominator, I'm going to keep the sign. There's a minus sign in front of it. It needs to have that sign. I'm going to write the 3 second. The 3 didn't have a minus sign in front of it. Because it's second, I have to have some sort of sign. I'm going to tag a plus sign. So that would be my first step for any of these problems. If the letters aren't lined up, I'm going to line them up. Here, in both the numerator and the denominator, there's not a common factor, and there's not an exponent, so I'm not going to get 2 parentheses. Most of these problems, I'm going to be able to factor out a -1, which we do in section 1.1. And in this case, I'm going to factor out a -1 from the denominator as opposed to the numerator, because in the denominator the negative is written first. So in the denominator I'm going to do a -1 and then a parentheses. And when you factor out a -1, you cause signs to change. The negative in front of the y is going to flip to positive. The y is not going to go away, but its negative sign is going to go away. The 3 is not going to go away, but the plus sign is going to flip to minus. So I've lined up my letters, factored out a -1, now I'm going to cancel. The y minus 3 in the denominator and the y minus 3 in the numerator will cancel. The y minus 3 in the numerator turns into a +1. The y minus 3 in the denominator also turns into a +1. And the -1 in the denominator doesn't go away. So I'm left with 1 over -1 times 1, which is, I'll let my calculator do that. So I'm going to go 1 over -1, using the minus in the parentheses to enter a negative number, times 1. And my calculator tells me this whole thing reduces to -1, because this is 1 over -1, positive over negative, the negative, and the fraction goes away. If I want to check any number I plug in to the original problem, I should get -1. There's no numbers to plug into my answer just because there's no letters. So if I wanted to check, if I picked a number like 2 and plugged 2 into the original problem, it better reduce to -1. So I'll try that just to make sure I haven't messed up. So fraction 2 minus 3 over 3 minus 2. When I plug that in number 2 into the original problem and reduce, I get -1, which is the same as my answer, so I believe my answer is correct. Alright, almost done. 42, the letters are already lined up, so I don't have to go through the step of lining up the letters and the numbers. So the rewriting step is not necessary for 42 because the letters and the numbers are all lined up. But there's a term or a piece that has a negative written first. And in this case, it's the numerator. So when I go to do 42, I'm going to factor out a -1 from the numerator. And I'm not going to do anything to the denominator to start. So if there's a negative in front of the letter and the letter is written first, I usually factor out a -1. When I factor out negatives, negative signs flip to positive. So this -3x becomes a +3x. The -7 becomes a +7. Now I'm ready to cancel. The 3x plus 7s will cancel. They technically turn into 1s. So when I cancel, I technically get -1 times 1 over 1. I don't need to write a fraction when it has a 1 in the denominator. So I could have just as well written that. And -1 times 1 is -1. So I claim this is my answer. Again, if I want to check, if I took a number like 2 and plugged it in for x, and did -3 times 2 minus 7 over 3 times 2 plus 7, it better be the case that when I do that, I get -1, because there's no place to plug that 2 in my answer, which tells me, regardless of the number that I plug in for x in the original problem, then I better get 1. So there's the plugging 2 in for x's, and I do get negative 1. So I believe my answer is correct because I get negative 1 when I plug 2 in for x. And again, I could have picked a different number than 2, but 2 is a nice number to pick as long as it doesn't give me an error message. 44, I need to line up the letters because the letters aren't lined up. So I like the letter first and the number second, so I'm going to write in the numerator the 2 first and the 10 second. The 2 keeps its negative sign. The 10 is not worthy of a negative sign because it doesn't have one to start, so it needs a plus sign. I can't cancel. I can't just only factor out a negative because there's also common factors. In the numerator, I want to factor out a negative because the first term is negative. But in addition to the negative, because both 2 and 10 are divisible by 10, I'm going to factor out a 2. So in the numerator, I'm going to factor out a negative 2. And after I factor out that negative 2, I switch the signs. The negative 2x is going to turn to a positive. The positive 10 is going to turn to a negative. And I need to divide the numbers by 2. And in the numerator, when I factor out a 2, I'm left with an x and a 5, and I fixed up the signs because I factored out a negative. In the denominator, there's no need to factor out a negative because the number in front of the x isn't negative, but I do need to factor out a 3. When I factor out a 3, I'm left with an x minus 5. I didn't do 2 parentheses because there weren't any squares in my factoring, so there's just common factor factoring. Cancel the x minus 5s. I claim my answer to 44 is negative 2/3. Again, if I want to check, I usually plug in 2 for x. So I'll come up here and go 10 over 10 minus 2 times 2, and then 3 times 2 minus 15. For this answer to have any chance of being correct, this better reduce to negative 2/3. So again, it takes me seconds to do. 10 minus 2 parentheses 2 over 3 parentheses 2 minus 15. So that's plugging in 2 for x in the original problem. Reduce it, reduces to negative 2/3, which is the same as my answer, so I assume my answer is correct. I think the last problem, but maybe there's more. It is the last problem. 46, line up the letters because the letters aren't lined up, which means in the numerator I need to line up the x's. Unfortunately, lining up the x's isn't enough. So I lined up the x's and the numbers. In the numerator, there's a negative written in front of the x term, and it's first. I usually factor out a negative. So I'm going to factor out a negative 1 from the numerator. Change the negative x squared to a positive x squared. The positive 36 to a negative 36. The denominator doesn't have a negative written first, so there's no need to factor out a negative. And it doesn't have a common factor. The denominator, nothing's going to happen to it. After I factored out the negative 1 from the numerator, I'm left with something with a square, and it's a 2 parentheses factoring. The numerator, it's going to factor into x plus 6 times x minus 6. And now I'm going to cancel the x minus 6's. And I get 2 perfectly correct answers. One leaving the negative 1 in front of the parentheses. This would be okay. If you want to, you don't even really need to write the 1. You could just write the negative sign. And if you want to, you can distribute the negative through the parentheses. Go negative 1 times x and get negative x. Negative 1 times 6 and get negative 6. All of these are perfectly correct answers. This is the one I'd probably write, but that's just me. If you wrote one of the other 2, it's okay. Let me check. I'm going to plug in 2 for x here. I'm going to go negative 1 times 2 plus 6. And up here, I'm going to plug in 2. I'm going to go 36 minus 2 squared over 2 minus 6 and see if I get the same results. So up here first, so 36 minus 2 squared over 2 minus 6. When I plug 2 into the numerator and denominator of the original problem for x, I get negative 8. Now to my answer, I'm going to go negative 1 parentheses 2 plus 6. try that again. -1 parentheses 2 plus 6. I also get -8. Because I get the same number when I plug in 2 to my answer as the original problem, I believe my answer is correct. So that's everything that I wanted to do for section 2.1. So hopefully you're not feeling too overwhelmed by this section. You need to have this section perfectly understood in order to do section 2.2. Section 2.2, I could have just included all the problems in section 2.2 as part of section 2.1. You won't find really anything new in section 2.2, so that's going to be a lot shorter section. So again, if you haven't ran and got this calculator yet, I'm going to use this calculator through the entire semester, and it's better than any calculator that you can have for this particular class. This is way better than the graphing calculators that you might own or any other scientific calculator that you might own. And again, this is the number on it, and I will use it, almost daily, or at least a couple. In every chapter, I'm going to use it. So you're going to want to get this as quickly as you can. All right, so if you're feeling a bit overwhelmed, you should come visit me, send me an email, and let me try to help you out before you get too far lost.